something unusual is unfolding above Saturn. Astronomers using NASA's James Webb Space Telescope, JWST, have detected strange, bead-like structures and an uneven star-shaped formation in the planet's skies, phenomena unlike anything ever seen on another world. The discovery, published in Geophysical Research Letters, has left scientists puzzled about their origins. Quote, "This was our first opportunity to observe Saturn's upper atmosphere and aurora in such detail using JWST's near-infrared instruments," explained Professor Tom Stollard of Northumbria University, lead author of the study. End quote. "The findings completely caught us off guard. A rare glimpse at Saturn's equinox." On November 29, 2024, Webb's Near-Infrared Spectrograph, NIRSEPC, monitored Saturn continuously for 10 hours. The observation coincided perfectly with the planet's approaching equinox, a rare event that happens only once every 15 Earth years, when sunlight evenly illuminates Saturn's equator. During this time, the planet's rotation allowed researchers to examine both the upper ionosphere and the lower stratosphere, two regions that have long been difficult to study. In the ionosphere, over 1,000 kilometers above Saturn's cloud tops, JWST spotted something extraordinary: a chain of dark, bead-like markings embedded within glowing auroral ovals between 55 degrees and 65 degrees north latitude inside the planet's sub-auroral zone. Quote, "Until now, emissions from this part of Saturn's atmosphere were far too weak for us to study in detail," Stollard said. "JWST's incredible sensitivity has completely changed that, revealing structures we've never seen anywhere else." End quote. A lopsided star beneath the beads. Roughly 500 kilometers lower, within the stratosphere, JWST detected another enigma: a distorted, four-armed star shape stretching from Saturn's polar cap toward the equator. The figure resembled a six-pointed star with two arms missing, giving it an eerie, unbalanced appearance. These two strange features, the beads above and the star shape below, appear to be stacked directly on top of one another, separated only by hundreds of kilometers. This alignment hints at a possible vertical column of activity running through Saturn's upper atmosphere, though the link between them remains uncertain. Quote, "The darkest beads seem to line up with the most prominent arm of the star shape," said Stollard, "but whether this is just a coincidence or a true connection, we don't yet know." End quote. A clue tied to Saturn's most iconic feature. The discovery may connect to one of Saturn's most iconic features, its hexagon-shaped storm, first seen by NASA's Voyager spacecraft in 1980. This massive, six-sided jet stream circles the planet's north pole, though its internal mechanisms are still not fully understood. Researchers now suspect that JWST's asymmetric star formation might be related to the dynamics of this deeper hexagonal vortex, suggesting that unknown processes could be at work within Saturn's stratosphere. Quote, "The uneven star pattern points to atmospheric motions we've never observed before," Stollard said. "It could be linked to the hexagon's powerful circulation deeper down." End quote. The beads, a mystery of motion. The dark beads themselves remain one of the most perplexing findings. They don't resemble any known patterns from Saturn, Jupiter, or other planets, and they're unlikely to have formed from ring material falling into the atmosphere, a phenomenon known to influence Saturn's ionosphere, especially around the magnetic footprint of the moon Enceladus. Yet no such signals were found in this region. Instead, Stollard's team proposes that the beads could arise from turbulent wind shear in the upper thermosphere, where opposing air currents, some rotating faster than the planet, others slower, collide. These conditions might produce Kelvin-Helmholtz instabilities, the same type of fluid interaction that on Earth creates rolling wave-like clouds. In Saturn's case, such instabilities could manifest as the dark bead-like shapes observed by Webb. Quote, "We think it's unlikely that these structures come from deeper atmospheric layers or external material," the authors wrote. "They're probably created by shearing winds within the ionosphere itself." End quote. JWST's unmatched vision. Even NASA's Cassini spacecraft, which orbited Saturn from 2004 to 2017, struggled to study the planet's dim upper atmosphere. JWST's unparalleled infrared sensitivity is now uncovering what Cassini couldn't. Quote, "These formations were totally unexpected, and at this point entirely unexplained, but they could offer vital clues about how energy flows through Saturn's upper atmosphere and how its auroras are powered." End quote. The data might also shed light on similar processes occurring in Earth's thermosphere, where comparable dynamic interactions take place. Additionally, researchers were able to revive a long-lost measurement from the Cassini mission, the planetary period phase, which tracks how electrical currents align with Saturn's rotation. Understanding this could refine models of the planet's magnetosphere. Stollard and his team hope that JWST will continue monitoring Saturn throughout this rare equinox period, when shifting sunlight could transform these strange atmospheric patterns. Quote, "Neither of these layers can be studied from the ground," Stollard emphasized, "so it's crucial that JWST continues observing Saturn during this key seasonal transition before the opportunity passes." End quote. Unlocking Saturn's hidden dynamics. The James Webb Space Telescope's findings mark a breakthrough in planetary science. For decades, Saturn's upper atmosphere has remained one of the least understood regions in the solar system. Even with advanced missions like Cassini, researchers struggled to see past the thick layers of gas and haze that conceal its deeper mysteries. Now, JWST's unmatched infrared sensitivity has peeled back that veil. For the first time, scientists are able to trace the delicate balance between Saturn's auroras, ionospheric winds, and stratospheric circulation, three systems that appear to be working together in ways never before observed. "This is a whole new layer of understanding," said Stollard. "The patterns we're seeing may reveal how Saturn's atmosphere transfers energy from its magnetosphere all the way down to its lower layers. That's something we could never track before." The findings could reshape what scientists know about gas giant weather systems in general. If Saturn's skies host such complex layered structures, similar phenomena might exist around Jupiter, Uranus, or Neptune, just waiting for JWST's instruments to reveal them. A planet of patterns. Saturn has always been a world of order and geometry, from its iconic rings to its polar hexagon. Yet Webb's discovery shows that beneath this order lies a world of asymmetry and turbulence. The four-armed star seen in the stratosphere might represent an uneven response to the same atmospheric currents that sustain the hexagon storm below. The missing two arms could mean that something in Saturn's climate has shifted since the last equinox, perhaps altering the balance of winds across the pole. Meanwhile, the beads higher up may be visible signs of energy transfers or localized turbulence zones, areas where winds in opposite directions collide, producing waves or eddies that briefly distort the thin ionospheric layer. "These features don't behave like normal cloud systems," Stollard explained. "They may instead be signatures of electromagnetic and plasma interactions, which are much harder to observe directly." Lessons beyond Saturn. Understanding these strange shapes on Saturn isn't just about one planet. It's also a key to understanding planetary atmospheres everywhere. By studying how Saturn's magnetic field and winds interact, scientists can refine models that explain how energy, radiation, and motion influence other worlds, including our Earth.
On our planet, similar Kelvin-Helmholtz instabilities occur in the upper atmosphere and oceans, producing the beautiful wave-like clouds sometimes visible before storms. If these same physics apply to Saturn, it means universal laws of fluid motion are shaping environments across the solar system. This is exactly what JWST was designed for, Stallard noted. Not just to look at distant galaxies, but to give us a new view of the familiar, to show us that even in our own cosmic backyard, there are still phenomena we don't fully understand. What comes next? The research team hopes to follow up these observations during the next phase of Saturn's equinox, when sunlight begins to shift toward the southern hemisphere. This period may bring dramatic transformations in the planet's auroras and high-altitude weather, potentially revealing how these strange shapes evolve over time. Because Saturn's upper layers are invisible from Earth-based telescopes, continued use of JWST and future missions is essential. Additional data could confirm whether the beads and star are transient effects or stable, recurring patterns linked to Saturn's internal energy system. Our current view might just be a snapshot in time, Stallard said. What happens when the sunlight angle changes? Do the shapes shift? Do they vanish? These are the questions we hope to answer next. The results also highlight how collaboration between ground observatories, past missions like Cassini, and powerful new telescopes like JWST can build a more complete picture of a planet's behavior. Every image Webb captures of Saturn seems to challenge old assumptions, proving that even after centuries of observation, the ring giant still holds countless surprises above its golden clouds.